in pre-calculus, we used to have a section called library of functions, and they changed the name of it to 12 basic functions, which I don't like as much as a library of functions, because I like to think about being at the level that we are in mathematics, that we should have this little library in our brains of certain graphs. Like, we should know when we see a certain equation, we should know what it looks like. Like, when we see x squared, we should know it's a parabola. And there's a whole bunch of other ones that we should know what they look like, and then that's going to help us when we talk about transformations of graphs, which is the next section before our unit test. And so today I'm going to give you a graph. We're going to talk about the domain and range, and I'm going to give you a little fact about that graph. Not an important fact, just something to keep you awake maybe. So I would recommend sketching these graphs on your paper, but it's your choice of how much you want to do. You don't have to make giant graphs. You just want to get the general shape of when I see this equation, I know it's this shape. Right, Taylor? Okay. I'm recording. Don't sleep. Like, don't put your head on your hands, and it'll be a lot easier to not sleep. My child hasn't slept longer than 2 hours at a time in the last 4 days, so I think he can stay awake. And last night, because he's sick, last night we were up at 10:30 and 12 and 1 and 2:30 and 3 and 3:30 and 4 and 4:30 and 5.
You're making me like.
I'm just saying, I don't have, like, you can stay awake. And I don't drink caffeine, so.
So what do you take?
Water. I just run on fumes. Mom energy.
Yeah.
Leave your mom and you're used to. You already have one kid. There's my excuse.
Doesn't make it better. I still don't get to sleep.
Are you saying that you have a kid anyway?
She doesn't have a kid. That's the point she's making.
No, I
I'm with you. Right. She's saying her nephew and nieces make her not want to have kids. That's what she's saying, kids. Not that she has good birth control. They weren't following you very well. I get what you're saying.
Thank you. I was gonna
She's saying she has good birth control in that her nephew and nieces make her not want to. You're with me?
Oh, wow.
I'm with you. I'm with you.
That's just.
Yeah, that's right. The identity function.
Oh, we couldn't record your conversation on it, but we can record mine.
Well, we wouldn't talk so loud. No one even know it's you.
Sounds like Taylor has kids.
I don't care. We'll never talk about it.
The identity function is the function just y equals x. That's just a linear function. It has a y-intercept of 0. It has a slope of 1. It will come back.
When it does that, does it record that too?
No, I think so.
I hope it was lost everything.
Taylor, don't be a jerk.
Oh no, I'm talking about recording.
I think it's this giant amount of cords over here, but they say they can't do anything about it, so.
Well, they clearly have not taken it.
Well, it's Mr. McDonald.
Come on.
Yeah.
Oh, look, it skips to the next one.
Oh yeah, it is.
Let's see if this is still recording. Still going. Still going strong.
So what was your conversation about the other week?
So just so you know, any linear function is really a transformation of y equals x, but normally we don't think about it as stretching and shrinking this because we just use slope-intercept form. But today, on your homework, if you see just a straight line like this, you know it's the identity function, because that's part of your homework today, is just matching up the name with a graph that looks like it. How about that? What would the domain and range of any linear function be? Yeah, it keeps going in both directions, so the domain is negative infinity to infinity. I feel like that's better than set notation, but if you like set notation and the answer is all real numbers, you need to really say where x is a real number. But I like negative infinity. You don't have to write this down, but I got these from my pre-cal book, and I like to give them to you. Interesting fact. This is the only function that acts on every real number by leaving it alone, because no matter what x you plug in, you get the exact same y out, right? You plug in 100, you get out 100. Plug in 7.2, you get out 7.2. Yes? Not that interesting. They get better. You don't have to write that down, but It's the only function that acts on every real number by leaving it alone, right? We don't do anything with it. If you made an XY chart, whatever number you plugged in, you get that same number out. Don't write any of those down. How? That's true. But it could have less than that. Like, a fourth power could only have one term. The book, both pre-cal book and this book calls this a squaring function. I like to call this a quadratic function. So if I use quadratic function, I mean squaring function, so both of those would be used interchangeably. And that would be any x squared, right? This basic one where the vertex is at 0, 0, this is what I call the parent function, and then we can transform it, move it left, right, up, or down, stretch and shrink it. And again, you don't have to make a lot of, like, if I was graphing this on my notes right now, I would do this. Like, I wouldn't make any marks on my x and y axis. You're just trying to get the general shape down. What would the domain of x squared be? Yeah, x could be any number, and there's a nice way to think about if you could draw your graph without ever lifting your pencil up. What? Well, that's a continuous function. I don't think that would mean the domain's always all real numbers. Never mind. I take that back. What about the range on this one? Is it all real numbers? It is, including 0. Every quadratic function is going to have a range that stops somewhere because it has a max or a min. I would write this as bracket 0 to infinity, or what would we say there? X is greater than or equal to 0. You don't have to write this interesting fact down. But this is a parabola, and it has a reflection property that is useful in making flashlights and satellite dishes. Remember when you say you never use math? You watch satellite TV? Thank you, math. You use a flashlight? Thank you. Thank you. Math?
Get a flashlight right there, gone the next minute. I used to
Seriously, kids. And headlights. You're right. All right.
But wait, how does the light thing? Why does this have anything to do with that?
Because it's the shape. If you like in a flashlight or a headlight, like it's the shape that makes it go out. So instead of just looking like this, the parabola is what makes it go out and give you a bigger area.
Thank you.
What? They call this the cubing function. I call it a cubic function. Again, same thing. That's just y equals x cubed. I always remember this as like a little S-shaped graph. One second, I'm going back for a minute. I forgot something. We could say this is a good example of an even function if you want to throw that in there because it's the same on both sides of the y-axis. What made me think of that is that the cubic function is a good example of an odd function because it's the same here and here, like they are opposite. I always think of this as like a little S-shaped graph. I don't know, that's really an S. I don't know why I say that, but that's what I think of. I know, but that's what I think of.
More like a 2.
Sideways, out, backwards, sideways.
It's like a 2.
What would the domain of this function be? Yeah, so far all of them have a domain of all real numbers, which means a pretty good guess is to guess domain of all real numbers. If it doesn't have a fraction, if it doesn't have a square root, a lot of times it has a domain of all real numbers. Cole Stevens, I don't know if any of you know him, it's been a while, but in Algebra 2, he always said he was guessing all real numbers, and he had a pretty good guess. Like, he would get it right most of the time, because the domain is almost always all real numbers in these functions that we talk about. What about the range on this one? Yeah, it's also all real numbers, because one arrow goes down and one arrow goes up, so they go in both directions. Negative infinity to infinity. You don't have to write this down.
No, I wrote that on my test.
Because you wrote what?
All the numbers.
Because that's not in correct notation. You have to write it in set notation or interval notation.
What's interval?
He just wrote all real numbers. This is interval, this is set notation.
Oh,
He just wrote all real numbers with nothing. No brackets, nothing.
I was like, what is that? This interval.
Sorry. This is what we call a point of inflection. In calculus, we're about to learn about these things. And it's where the graph changes from concave down to concave up. How exciting is that? Okay, moving on. This is the reciprocal function. I like to call this, what do I call this? A rational function. I have my own name for all these, apparently. They call it a reciprocal function because it's the reciprocal of x, right? This is your equation, 1 over x. And it's just these kind of L shapes. Maybe you have some vague memories of graphing those in Algebra 2 or pre-cal. Chapter 9 in Algebra 2. Yeah, and this would be one that does not have a domain of all real numbers. This goes against my good guess of all real numbers. But again, look at the equation. We've just talked about domain. If you see a fraction and there's an x in the bottom of it, your domain is not going to be all real numbers, right? What can't x be in this problem? 0. And if you look at the graph, it never touches the x-axis because you cannot take 1 divided by 0. So your domain is everything but 0. And again, I don't care if you write interval or set notation. Set notation isn't bad on this one. I'll do it both ways. Set notation, we'd say x such that x is everything but 0. And a nice math way of writing that is saying x cannot equal 0. Or interval notation, you'd say negative infinity to 0, and then 0 to infinity. The range may be a little bit harder to do if you didn't look at the graph on this one. But the range is also not going to be all real numbers because what y value is that graph never going to get to? 0, because it has these asymptotes where it's never going to get to either one, the x or the y. So it just means union. So you just, when you write this, I don't know, have we talked about that in here?
Yeah.
That you should always put that in between there. I don't usually mark it wrong, but if you do it like this, then you technically should put a u in between that. It just means like this and this together. Just kind of mathy stuff. So my range is going to be the exact same thing, except for if you write it in set notation, if you're talking about range, you need to say y cannot equal 0. I totally did that wrong earlier when I said it wasn't ever going to touch the x-axis, but that's right. But in interval notation, it would look the exact same, everything but 0. And again, the fraction should be the big clue on that one. And technically, this is a hyperbola, which is also useful in satellite dishes. Thank you, Math, for giving me my satellite TV. There's other satellites, right? I'm sure there's satellite for everything. You might not have, yeah, like thank you for the cell phone coverage that I get.
It's a movie I started watching last night.
I don't know.
I want this at all, and it is really good.
Square root function, again, it's one of those that you should recognize. When you see an equation with a square root, you should think about it is half of a parabola on its side. That's how I always remember a square root function. Again, looking at the equation, it has a square root in it. Is my domain going to be all real numbers?
No.
No, because fractions and square roots are the big things that I cannot have everything in there. What can't I have in a square root?
0.
I can take the square root of 0. It's 0. You can't have negative. So that's why when you're doing domain of square roots, you just set what's under the square root greater than or equal to 0. And in this one, if I set that greater than or equal to 0, I have nothing to solve. That's just my domain, but I'm not going to leave it like that, right? I got to put those little things around it. Or we could say bracket 0 to infinity. Both of those would be okay. Any number 0 or larger would work in that problem. What about your range on this? Is your range going to be all real numbers? No, because only half of a parabola. It's either going to be up here or down here or maybe moved around. But your range is not going to be all real numbers. Where do my y values start on this problem? And they get bigger or smaller? They just get bigger. So is my range going to be the same as my domain on this one? Yeah. Or 0 to infinity. How about this one? Everyone's going to stop paying attention and do this on the calculator now. Put any positive number into your calculator, take the square root, and then take the square root again, and then take the square root again, until finally you'll always get 1, no matter what number you start with.
No matter what number.
No matter what number. You start with a decimal even. And you just keep taking the square root. The problem is, I don't know how my calculators work so well if you just get to keep hitting square root of the answer. But it always works. Equally. It always works. What? How many of these do we have so far?
No. Well, that's not fair because after so long it just goes 1 point.
That's the idea of it. Like, if you keep taking the square root number, it keeps getting smaller, closer to 1, and then eventually you just get 1. It's math. It's not a trick. Look, I didn't draw this one. Cube root is when you have not x cubed, but you have the inverse of that, the cube root of it, and that's when you have like a graph like this. That's kind of a S, right?
Yeah, elongated, like stretch. So yes.
I don't know why I call everything S's, but this one is not in the pre-cal book as one of the 12 basic functions that they expect you to know, but it's in this book. That's why I had to draw my own graph. No, I don't know how many there are. I think there's less than 12. I kind of forget. I made these notes on Friday when I came back with my sick child from daycare before I went home. And I came in here and tried to make notes with the child walking or crawling all around, trying to eat the cords and everything else. So I kind of don't remember exactly what's going on here. It's good for you to write then. No. What's the domain of this? What about this root? How come I can have negatives in that one? Because it's odd. Odd numbers, you can take the cube root of an odd number, and notice it goes in both directions. So that's how you can verify that it's negative infinity to infinity. And what about the range on this one? Yeah, it goes up very slowly, because when you take cube roots, like the cube root of 27 is 3, so you'd have to go all the way out here to 27 before it would come up to 3, but it is going to eventually keep growing. So we would say it's also negative infinity to infinity. And because cube root and x cubed are inverses of each other, my interesting fact is the same, is that this also has a point of inflection that where it curves, where it changes concavity. Funny, right? I know, it's calculus. Nobody knows but me. I don't know, in some other class you talk about concave and convex, right? Did you talk about that somewhere? But in calculus, we talk about concave up and concave down. So this would be concave up, and then it turns to concave down. At calculus, we define that about tangent lines, and I don't think you want to talk about that right now, so. I think I got at least
lost right now. I feel like I stepped out of college for like
That's how I feel about, I was telling Miss Hodge on our walk back from Veterans Day, that's how I feel when I watch the band play, because I'm just so, know nothing about playing an instrument, and I'm just amazed that they can play instruments and make music come out of it. And then Mr., what's the band teacher's name?
Rice.
Mr. Rice, I love watching people conduct, because my roommate in college was a music education major, and she took a conducting class, and I thought it was funny, because I had always thought they just, there was nothing, I just thought they did this, I didn't know there was real things that you do to conduct. And I just think it's cool that he does things, and then people know what he's doing to know what they're doing. And
You were really.
I feel like when people come into calculus and they're like, "Oh my gosh, I have no clue what you're saying." Like Mr. Bain came to pre-calculus one day to observe me, and he was just like wide-eyed the whole time. And he said, "I'm never coming back to your classroom. I cannot handle that. I just feel like I understand how people see math and they think that it's like a foreign language, because I see people playing instruments and making music out of it." And people conducting, and the people that are playing the instrument knowing what that means, and it's baffling to me. Supposedly maybe, but I got nothing. You heard me sing on Pi Day, remember? I like to sing, but I'm not good at it.
Can you sing in your car?
Sometimes. We have Phineas and Ferb CD in my car right now, and we rock out to some Phineas and Ferb. We have time. Kendra, I have to show you that we made Phineas's head cake this weekend to practice for the birthday. I have to get your opinion on it, which we're going to change a few things, but I was pretty impressed. My husband made it. I can really take no. Nobody's. What? You can ask Parker. You can. I told my husband that I told students that they could come because I don't think any of his friends are coming, and he's like, no, we're not having high school kids come to our 6-year-old's birthday.
Why? That's awesome.
Yeah. Absolute value. Absolute value is a V-shaped graph. It is the only graph that we graph that has a sharp corner on it besides piecewise graphs. So if you see absolute value, which we always show as the symbols, sometimes the book writes ABS because that's how you do it on your graphing calculator. Like there's a button that says ABS that stands for absolute value. So just be aware that both of those mean the same thing. And what would the domain of this function be? It's kind of like a parabola, right? Only instead of being a nice curve, it's a point. So I think the domain and range is going to be the same. My range is going to be all real numbers? No, my range is going to be... And again, notice that this function has an abrupt change of direction or a corner, whereas other functions, that's why I'm kind of picky when I grade graphs. If you make sharp corners on polynomial functions, I say no sharp corners because absolute value is the only sharp corner graph. Yes? Nope. I don't know. It's a surprise. I think we have at least one more. I think we just have one more. But that's good. And then your homework today, you get to match up graphs to pictures. Like here's a picture and here's an equation. You just get to match it up. And if you see a V-shaped graph, you match it up to absolute value. If you see a U-shaped graph, you match it up to x squared, right? That's easy. And then you have some on your homework that you actually have to graph. And guess what? The exact same ones that you just drew in your notes. Oh, wow.
You know what my favorite thing to do is? On math homework, show my nephew and watch the
How old's your nephew?
13. Are you gonna do this for 4 years?
The greatest integer function, in general, we call these step functions, but the specific one that we learned about in Algebra 2 and the one that we talk about in this class is called the greatest integer function. Let me see how the book writes this one. INT, again, that's a button on your calculator, which is why they write it like that. Yeah, that's it. Wow. Yeah, they just write it like that too. INT.
I haven't had either one of these last, but on my computer.
I know, they're on graphing calculators, honey.
Oh.
In Algebra 2, I think you kind of wrote it like that. Do you remember that, maybe? Double bracket, maybe?
I'm gonna draw this.
Just make some steps. Closed circle to open circle, and then wherever your open circle is, the closed circle is right above it.
I thought we go to bracket and then a big bracket.
Maybe double bracket.
Yeah.
That'll work too. The idea here is knowing what this means. This means the greatest integer less than or equal to x, which is kind of a weird definition. I don't know why I even write that, but that's the way the book writes the definition of that. What that means is that you always round down if you plug a decimal or a fraction in. No matter what you plug into that problem, if you have a greatest integer, you always round down to the next greatest integer, which I just feel is confusing in itself. Why would you say round down greatest integer? But let's practice some. If I said find the greatest integer of 2.7, I wrote a bracket instead of a 7. 2.7. You would say, I can't get a decimal out of there. I have to round down to the next whole number. That would be 2. Even if I put like 5.999, that's going to be 5. So that's why when you graph this, you get these steps. Anything between from 0 all the way up to 1, any number that you can think of is going to round back down to 0. But then when you get to 1, it jumps up there, and anything between 1 and 2 rounds back to 1. So that's how you get these steps in your graph, because you only get whole numbers out of it. You don't get decimals. So let's think about our domain and range on this one. Domain. Could I plug any number I want into this problem? Could I pick any x that I want? Yeah, I can pick decimals and fractions. So the domain is still all real numbers. Can I get any number out of this? What can I only get out of this? I only get integers out of this. I can only get 0, 1, 2, right? It steps, it jumps at each integer. And so we have to write this, like I don't think you could write this in interval notation. You have to say your range is all integer. So you could say where y is an integer. Or if you just wrote y such that all integers, I would count that, okay? But we'd have to say that it's an integer only because it jumps, all right? That one's kind of weird. There are none of those on your homework that you have to graph yourself. But you just, again, want to recognize it. When you see that you're like, oh, that's a set function. Oh, look, that's a step function. That's all that says. I think we're done. Let's see. I think so. How many was that? 8. See, that's not so bad. That's it. Your homework, your notes here, we don't need to do any examples because your notes should help you do your homework. And 9 through 16, you're just matching a shape of a graph to a name of a graph. Like it's just like matching A through H with 9 through 16. Like no work needed. But then 17 through 24, you're going to graph those, and you're welcome to just graph them on your own paper, or if you want to graph on graph paper, you can. But you're just going to draw the graphs yourself. If you want to make a few points, you can. Make an XY chart, you can. And then tomorrow we'll talk about piecewise functions, and then after that we're going to talk about transformations of your graphs, like how you can stretch, shrink, vertical, shift, horizontal, shift, all that jazz. Shift. Dilation. Anybody want graph paper? Graph paper, graph paper, graph paper. I think there's 8 that you have to graph, but they're just the basic ones. So you only have about 4 minutes, but I'm telling you, you can get 9 through 16 done before you walk out the door here. You just open your book and play with paper because it's just matching the shape for the name. That's it.
So what you got?